In this problem, we're graphing systems of inequalities, which are conics. The first thing I would do is I would look at my formula sheet and determine what is the type of equation that we are graphing. When you have x squared and y squared, and it's a plus, you know that it is an ellipse. If you have only one term squared, you know it must be a parabola. To put the ellipse in standard form, you simply divide by 400 because you want it equal to 1. So I end up with the equation x squared, and I do 400 divided by 25, and you should get 16. And then do 400 divided by 16, and you should get 25. So that is the standard form for the ellipse. For the parabola, what we need to do is first put the constant with the x and move the y squared to the other side. So I have x minus 1 is greater than, and then I'm going to move the y squared term to the right. And now, if you look at your standard form equation, it always has the constant with the non-squared term. So I'm just going to multiply everything by 8. And then I have 8 times x minus 1 is greater than y squared. So that is the standard form for my parabola. Now for my ellipse, I see that the center must be 0, 0, since there it's just x and it's not x minus anything. The A must be 5 and the B must be 4 because I square root each one. Now, since I'm going to go to the center and I notice under the y, and this is what's really important, sometimes students get confused. Under the y is the 5, so I'm going to go 5 in the y direction. And under the x, it was 4, so I'm going to go 4 in the x direction. Now, I notice that this is less than. It's not less than or equal to. So it's very important that for that equation, you draw it as a dashed line. Okay, for the parabola, I see that the vertex is 1, 0. There's nothing with the y, and so the y must have a vertex of 0. The focal width is equal to the 8, and therefore the focal length, this is 4p, so 1p must be 2. So I'm going to graph the vertex 1, 0. And then if you look at your formula sheet, one that has y squared is a horizontal parabola. Since the 4p value is positive and it's horizontal, you know that it opens right. Positive is the right direction. So I am going to have a focal length of 2, so I'm going to go 2 over, and that will, from the vertex, that's the 2, that's for the p, and then the focal width is 8, so it's a total of 8, so I go up 4, and I go down 4. This time, since it's greater than or equal to, I am going to have a solid line. Now, my last step, since it's an inequality, is that I need to shade. The ellipse is pretty easy to figure out because the ellipse, you would see, is just less than, so we are going on the inside of the ellipse with our shading. So the ellipse, we're shading on the inside. For the parabola, we're going to have to test a point. Usually what I do is always test the origin. So let's put that in the equation and test. If I choose the origin to test, then I would have 8 times -1 is greater than 0. So -8 is greater than 0. That is false. Therefore, I am not going to shade the origin. I will shade on the other side of the origin is not part of our region. Things that are on the other side would be part of the shaded region. So let me switch to a different color. And I am going to shade with blue over here. And then my final answer is this section that's shaded by both. So this little section right here, inside the ellipse and inside the parabola, is the final solution.